Okay, I think we're just after 11 o'clock Eastern Time. I think we will start. My name is Bob Schumann. I'm with Unity Scientific. I'm in charge of product management and marketing. And we're very excited to put on this webinar today with one of our fellow KPM companies, CHOPIN Technlogies. I want to welcome everybody to the webinar. At the end of the webinar, we are going to have a Q&A session, so I would encourage everybody to use the Q&A panel that's over to the right of your screen. If you just press on the little caret next to Q&A, a screen will open up and you can type in questions, and I will be collating and reading all of those questions to Jayne and my colleague Gregory. So just please feel free to send questions to us during the webinar, and we will get to them at the end. And with that, I'd like to hand this over to my colleague in France with CHOPIN Technlogies, Gregory Vericel.
Thank you, Bob. So indeed, we are very happy to put this webinar together. I am Gregory Vericel, as Bob just told you. I'm the marketing director for CHOPIN and handling the marketing globally for our company. Today, we have the pleasure to have Jayne Bock as presenter for this webinar. She is a true expert in grain and flour quality. And she, as you can see right now on the screen, has worked extensively with wheat breeders, agronomists, millers, and food processors, which is going to be a special topic today. So now we're going to start. So Jayne, the floor is yours.
Thank you, Gregory, and thank you, Bob, as well. So today, I'd like to thank everyone for joining us. If you're on the West Coast, you're getting an early start to your morning. If you're on the East Coast, you're starting to think about lunchtime. And of course, Gregory, you're looking forward to the end of the workday. So thank you all for making time to be present for this webinar. So as Gregory mentioned, we are going to be talking about solutions for frozen dough applications today, a topic of increasing interest in the industry. But first, I want to talk a little bit about who we are as CHOPIN Technlogies. So we are part of the KPM Analytics Group, and that includes Process Sensors, Unity Scientific, CHOPIN Technlogies, and AMS services as well. And all together, we form KPM Analytics. So in terms of CHOPIN Technologies product offerings, we do offer a full range of products, starting all the way with sample preparation, including a number of grinders and lab mills. We do have instrumentation for compositional analysis, primarily NIR technology, but some ovens as well. We're most well known for our instrumentation for functional analysis, and we'll be focusing on these instruments today in terms of frozen dough applications. And then we also have some offerings in thermometry analysis, primarily for grain storage. So innovation is part of our DNA at CHOPIN Technologies. And just to give you a sense for what we've done in the last 15 years, we've been consistently offering new products, as well as reimagining some of our flagship offerings like the MixaLab and the Alveograph that you might be more familiar with. And of course, we do have a global presence, both direct through CHOPIN North America and of course CHOPIN Technologies in France, and also through our global network of distributors, as you can see. So let's go ahead and let's get into the meat of the topic here, and let's talk about instruments used for frozen dough applications. So we are going to specifically talk about 3 instruments today as solutions for frozen dough applications, and those include the Rio F4, the MixaLab 2, and also the Alveolab. And most of you will be familiar with the Mixolab and the Alveolab, but perhaps not as much with the Rio F4, so we'll spend a little more time on the Rio F4 today. So let's go ahead and look at the Rio. What this instrument is really designed to do is to look at behavior during the fermentation process. So if we look at this video here, what we're looking at is we're looking at a series of weights on top of a mass of dough. And so if we watch this video, as the dough proofs, it will rise and provide, it will gain in height against the weights that have been placed on top of it. So you will be able to measure an increase in dough volume during fermentation. Additionally, the instrument is also measuring CO2 retention and release. So as you can see here, as the dough rises, the yeast is producing carbon dioxide, and the sensor is sensing any release of carbon dioxide so that you can have a sense for how much carbon dioxide is retained versus how much is lost. And it's plotted out on a chart, as you can see in the video. And the difference between this top line here and this dotted line down here is the loss of carbon dioxide during the fermentation process. Now the Mixolab. Most of you will be more familiar with the Mixolab, and it is designed to tell a little bit more about mixing and baking behaviors as opposed to fermentation. So the Mixolab is a recording mixer with the ability to apply heating and cooling during the mixing cycle, typically on 75 grams of dough. This is a constant dough weight method. And the instrument can provide a very quick visual assessment of the flour or the dough along 6 dough quality criteria or indices. And those include water absorption, mixing, specifically a combination of development and stability, gluten strength, especially during heating, maximum viscosity during starch gelatinization, amylase activity, and starch retrogradation. So this is an example of a standard Mixolab curve. And what you can see is that during the initial phase of testing, when we're at 30 degrees Celsius, we're primarily measuring the gluten properties. We will begin to apply some heat, and beyond a certain point, starch properties take over as starch begins to gelatinize, and starch dominates the latter portion of the curve. And as you can see, here's an example of our spider graph, and you can see the 6 indices plotted along the edges of the graph. And it does provide a very quick visual indication of whether your flour or your dough fits within the prescribed green area for a given product. It's a very powerful quality control tool. And just to show you where those indices fall on the curve, this first portion of the curve for the first 8 minutes, where temperature is held constant, is where the absorption and the mixing indices are calculated. This gives you a sense not only for water absorption, but the mixing properties of your flour. During initial heating, this is what we call the gluten plus index. It gives you an indication of gluten strength specifically during the heating phase, so how well the gluten manages to continue providing structure during the initial phase of heating before starch gelatinization takes over. As temperature continues to rise and the protein denatures, starch gelatinization takes over, and this is the viscosity index. Once we reach maximum temperature and we hold, we can start to see the effects of amylase in the breakdown of the viscosity curve. And then during cooling in the final hold, we do see this retrogradation or setback phenomenon, and we can get a sense for potential shelf life of the final baked product. And third, we have the Alveolab. As opposed to measuring fermentation or mixing properties, the Alveolab is really designed to give you an indication of your dough viscoelastic properties, that balance of elasticity and extensibility. So during the test, we mix the dough for 8 minutes and then extrude the dough patties. at which point we allow them to rest for 28 minutes before blowing the bubble. And I'm sure most of you are familiar with this portion of the test. But as you can see here, we're blowing air into the bubble, and we are measuring the resistance to deformation as well as the extension of the dough before the bubble bursts. And there you can see the bubble has burst. So here's an example of a typical alveograph curve. So the p-value basically gives you an indication of dough elasticity. It's the resistance to deformation. And the p-value is the maximum point achieved by the curve. The L value gives you a sense for extensibility, or how far you can stretch the bubble before it ruptures. The P over L value basically gives you the balance of elasticity to extensibility. The elasticity index is a ratio of the pressure 4 centimeters into the curve over the maximum pressure. And this gives you a sense for how quickly the dough starts to expand after the initial resistance is overcome. It gives you a sense for slope of the curve, I should say. And then finally, the area under the curve gives you a sense for baking strength, because this is the energy to form the bubble before it ruptures. And as you can see, these are just visual cues for what each of these parameters are. So resistance to deformation, extensibility, and then the balance between the two. So with an introduction to the 3 instruments, let's start talking about how our solutions can help you with your frozen dough applications. So as we all know, baking trials and analytical instrumentation, they work hand in hand. But the thing about baking trials is that they're expensive, they're time-consuming. You need an expert test baker because the results are very operator-dependent. So our solutions are designed not to replace baking trials, but to reduce the number of baking trials that you have to perform. Your baking trials should be focused on new and challenging formulations, not on testing good versus bad ingredients or flours. Baking trials are not a quality control tool. So our solutions are basically designed to help you have an objective and accurate result that's operator independent. Because what if your test baker is out for the day? What if they're out sick? What happens when your test baker retires? So this is some way to get some sort of objective measurement without necessarily resorting to a full test bake every single time. So frozen dough is a very challenging system. So if you're freezing after proofing and baking, this is par baking, you need to precisely control the proofing process to get the optimal product volume. If you're freezing before proofing, this is a true frozen dough. You're concerned about production of ice crystals because these ice crystals damage the gluten network and the yeast cells and result in a loss of product volume. So your gluten is less effective, so you need to add more vital wheat gluten, which costs money. Also, your yeast will be less active, and so you need to add more yeast or a freeze-resistant yeast variety. And of course, this also costs money. So in terms of controlling fermentation, the main products that we're looking at include things like pizza dough. It might be donuts, which is a chemically leavened system. It could be bread products. So the Rio F4 can be used to provide information on determining the most appropriate gluten to add, the optimal gluten addition rate. It can help you reduce costs by making sure you're not adding too much of your gluten. You can also choose the best performing yeast, for example. So as we all know, frozen doughs show lower gas production than fresh dough. and they retain less of that gas as well. So you can use the Rio F4 to control the impact of additives and freeze-resistant yeast on proofing performances. So if we look at these two curves here, we can see the non-frozen dough produces far more gas, and it tends to produce it much more rapidly than the frozen dough. So this is what we're up against when we're looking at fermentation of frozen dough. So in terms of evaluating yeast performance, the challenge is that different yeast yields different performance. So if we take a quick look at just the height developed during fermentation, you can see that two of the different types of yeast here are kind of along the same lines of performance, but this third yeast right here is much slower in terms of its gas production. And so this maybe isn't going to be as helpful in a frozen dough application, this particular yeast right here. We can also look at gas release. So if we look at these same three yeasts again, you can see that gas release occurs much later for this third yeast that has the slower development. So this means late porosity in your product. You can also see, comparing the other two yeasts, that gas retention is a little bit better in the orange yeast as compared to the blue yeast. Looking at gluten, you can use the Rio F4 to determine how much gluten you need to add, because gluten is costly and you don't want to add more than you absolutely need in your formulation. So if we take a look here, we can see that we get increasing amount of gas production and volume as we add more gluten to the frozen dough. And depending on the targeted volume you're trying to achieve and the time frame you're trying to achieve it in, a different rate of gluten addition will be optimal. But it's not just knowing how much gluten to add, it's knowing which gluten to add. So different suppliers, the gluten performance can be different between different gluten suppliers. And so when you're looking across different glutens, the performance can be quite significantly different. So you can see development here is much later for this gluten, the green line, versus, say, the blue line, or this looks like a brown line on my screen. So you can see that the timing of your fermentation is going to be very different, as well as the gas production. And of course, you can see the fallout too in terms of gas retention. So you can use the Rio F4 not just to identify the right amount of gluten to add, but you can also compare against different suppliers. So in terms of looking at the gluten, you can also evaluate it with the Mixolab and the alveograph. So if you look at the addition of gluten on a constant hydration basis, so if you don't want to change the hydration of your formula, you can see here the amount of energy that will be consumed during mixing of your gluten. And so you can make a comparison in that manner, or you can do adapted hydration, where you match the hydration to the optimal for the amount of gluten that you're adding, and you can start to see differences in the mixing properties in terms of development time and the stability, as well as differences in the starch pasting properties that will come out during the baking phase. So you can also use the Mixolab and the alveolab to evaluate and compare glutens in terms of different gluten suppliers and the optimal addition rate. So just to give you a sense for the possibilities, again, you can use the Rio F4 to select the best performing yeast, and you can make comparisons among different suppliers based on the proofing performance. You can also identify the most appropriate percentage of yeast to add to get the right fermentation timing and product volume. You can use it as a quality control measure to test among different lots of yeast, so making sure that the yeast performance is consistent from lot to lot. And you can also look at the impact of other ingredients on dough proofing. So maybe your frozen dough strategy includes the use of some soluble fibers, maybe a guar gum or a xanthan gum. You can evaluate the performance of those ingredients and their impact on proofing performance with the Rio F4. As I mentioned, you can also select the right vital wheat gluten from different suppliers and determine the appropriate addition rate. And then again, it's also a quality control check between lots to ensure consistency from batch to batch. In terms of the Mix-a-Lab, as I mentioned, you can choose among different suppliers of vital wheat gluten based on mixing performance. So what is the development time? What is the stability? What is the strength of the overall dough formulation? How much energy will you be consuming during mixing? And of course, you can use that to determine the most appropriate addition rate as well from a mixing standpoint, from a dough handling standpoint. And again, as a QC tool for checking for consistency between lots, and of course, the impact of other ingredients on dough mixing properties. And the Alveo Lab, all of the same applications, but in this sense, you're going to be looking at it based on a dough handling perspective, the balance of elasticity and extensibility. How is this dough going to handle on the processing line? And then again, after freezing and then thawing and fermentation. So there are customers already working on frozen dough applications that are using CHOPIN Technlogies solutions, including the Rio F4. And those include Rich Products and Maple First Bakeries, and there are several others out there using these instruments for greater control and consistency of their frozen dough applications. So just to bring things to a nice conclusion before we move into the Q&A session, our solutions are designed to help you with control of raw materials. So we all know that the more diversity you have between lots of your ingredients, the higher risk you have for inconsistency in your own production. We can help you in selecting and dosing the right ingredients and additives. We can help you anticipate and adapt to changes in the processing properties with our instruments. For example, changes in water absorption and mixing, or the dough handling properties. We can help you reduce the number of baking tests so that you can use it more as a new product development tool as opposed to your quality control tool. And we can also help you speed up the new product development test because now your baking trials are reserved for new formulations as opposed to looking for consistency in your production. So if you do want more information or if you're interested in a trial, you can contact Gregory at the email indicated. And then just to give a final wrap up, we have a wide range of solutions for the baking industry. And if we just look at these three instruments, they are all three suitable for frozen dough applications. Gluten-free, salt reduction, sugar reduction, clean label, and whole grain as well, with the exception of the Alveo Lab. So the Alveo Lab is not suitable for whole grain or gluten-free, but we do have a very wide range of applications available. And so with that, I will conclude the presentation portion of the webinar, and now we'll get to the fun part, the Q&A.
All right, thank you very much, Jayne. I would remind everybody out there that there is a Q&A panel over to the right. So if you have any questions, please just send them to me and I will get them to Jayne and Gregory. We've got one starting out that says, can the fermentation test time with the Rio instrument be modified or is it fixed, and what is it?
That's a very good question. So the fermentation test time with the Rio can be adjusted from anywhere between 1 to 24 hours. So it's really specific to your particular product and what you would be looking at as a reasonable fermentation time.
Okay. Got another question that says it sounds like there are similarities between the Mixolab and the Alveolab for frozen dough applications. What are the key differences between those two instruments?
So the Mixolab is really designed to tell you more about the mixing properties of a formulation, as well as how it might bake up in terms of the heating portion of that profile. The Alveolab is more specific to the actual handling properties and the balance of elasticity and extensibility. It's a better indicator of how your dough will handle on a processing line. So if you can think of the Mixolab as more of a tool to help you figure out mixing properties, and the Alveolab is more about the dough properties, that would be a good way to kind of keep the two instruments separate in your mind.
Okay. We have another one. It's also about the Rio F4. It says, can the fermentation test temperature be modified? Yes.
Yes, yes. So the fermentation temperature can be modified. There again, it can be very specific to your product. Obviously, you don't want to go too low in temperature, but that fermentation temperature can be adjusted.
Okay. Got one more that asks, can these instruments be used to test for shelf life or stability of frozen products? And if so, which one, or I guess would be ones, are better?
That's a really good question. I would say in terms of determining the shelf life of your frozen dough, how long can it remain frozen before you basically lose fermentation capabilities, I would recommend the Rio F4. You could do a very nice shelf life study and figure out what the shelf life of your current formula is, or you could use it if you're trying to achieve a certain shelf life target. You could also use the Alveolab as well, just to make sure that the balance after thawing, make sure that the balance of dough rheological properties is still where you want it in terms of handling capabilities. I don't know that the Mixolab is quite as relevant, but there is an application where you can take the dough. So after you thaw your dough out, you could theoretically put it into the Mixolab and look more at how the starch behaves during the heated portion of the curve. But I would say primarily the Rio F4 would be the instrument I use, with maybe the Alveolab and lesser emphasis on the Mixolab.
Okay. For adapted water absorption, what's the amount of water per gram of VWG?
So the adapted hydration is basically, it's determined based on what is optimal for your formulation. So with the Mixolab, you're typically targeting a 1.1 millinewton meter development or torque, I should say. So it's whatever water absorption is required with the vital wheat gluten to achieve that specific torque or force. So it depends on the formulation. It won't be a set number.
Okay. Another one, what would be the most desired results for Alveo, P, L, and W for frozen dough, in parentheses, pastry application?
So I can't give you exact numbers because there, again, it will be specific to your product. But obviously, with pastries, you are looking for something that's a little bit weaker in terms of its alveolab profile. You're not looking for something as strong as what you would maybe be looking for a pan-bred application. So something a little bit weaker than that, but it still has to have the strength to withstand the freeze-thaw process. So I can't give you a really good set of numbers to target, but I can tell you that it will be weaker than pan-bred. It'll be stronger than, say, your typical cookie or biscuit making flour. I don't know if Gregory wants to add anything to that.
Yeah, just a quick comment on that last question, because it's a good one. It's also a tough question to give specific values, because it's very much varies depending on the product and depending where these products are manufactured. If it's in the US or somewhere else in the world, it's not the same. For frozen dough specifically and pastry application, we also have to keep in mind that typically the target for frozen dough pastry will be the same as non-frozen dough pastry. The reference to match is usually the conventional, if I should say, product.
Okay. That is all the questions, I believe. I don't see any more. And with that, I think we're going to wrap up our webinar. This webinar was recorded. I will be sending a link with the recording to all of those, everybody that registered and attended this webinar. And I believe there might be some documents also that Gregory and Jayne have also. I'll include anything that is relevant for our audience. And with that, I would just like to thank Jayne and Gregory, and thank everybody for joining and spending some time with us on this webinar. And please get in touch with us if you have any questions. So, thank you very much to everybody.
Thank you, Bob.
You're welcome. Thank you.
Thank you.
Goodbye. Have a good day, everybody. Bye-bye.